Hello Clemoni, welcome to today's maths video lesson. I hope you're doing well. I was accused in my NS class for being a little bit too robotic when I was teaching. So it's a little bit tricky without an active audience to participate and give me feedback. But I'll try and do my best to make this maths a little interesting. But thank you so much for participating, for doing your Skype calls, for doing the homework, for especially understanding that tan graph. And I hope I hope you can just focus through these videos. I'll try and make them as short and sweet as possible, just capture everything that's relevant. So let's get started. So I'm just following off the worksheet that I sent you, the lesson plans for the week. And our second lesson was looking at these questions for exercise 11, page 135. Okay, so we're just recapping everything. So in a test or exam, they'll ask you questions and they'll include all the different kinds of graphs. So it's nice to do exercises like this just to be comfortable with everything. So the first question is question 1. Plot the following pairs of graphs on the same set of axes. Clearly show all intercepts of the axes, the coordinates of any turning points, and the equations of any asymptotes. Okay, so for 1a, we have two different graphs. The first one is y equals 2x over 5, and the second is y equals 5 over x. Okay, so two similar looking equations, but two very different pictures, because the first graph is a straight line, and the second graph is a hyperbola. So let's imagine some points. I'm going to bias my choice of points towards the parabola. So I'm going to choose points that help me out for that graph. And the reason is because the values for a straight line graph is very easy to draw. So I'm going to base my choice of x values on this graph. So because there's a 5 over x, I want to choose values of x that are multiples of 5. So I'd like to pick minus 25, minus 25, minus 20, minus 5, 5. I should choose 10. Sorry, let me choose 10. The reason I want to choose 10 is because if we have 5 over 10, then we get a half. So I like numbers like that are easy to plot. So let's do that again. Let me actually do minus 20, minus 10, minus 5, and do 1, minus 1, so that will give me 5 over minus 1 is minus 5, and fractions, I could do minus half. Okay, so I'm not going to do all of these points. I'm going to leave out a couple, but I'm just trying to get the range worked out in my head. So those are the negative values for x and the positive values. Let me make negative quarter as well. Sure, this is going to be too big though. So I should try and restrict it. I think I'll just restrict it to these. And then I'll mirror it with my positive values. So I'll choose a quarter, half, 1, and 5. Minus 5, minus 1, minus a half, minus a quarter. Okay, so I'm just going to plug and play, plot each of these values, in. So y 5 over minus 5 is minus 1. This will give us minus 5. minus 10, minus 20. And then we've got 20, 10, 5, and 1. Okay, so I'm going to plot that graph first. Let's see, our x values go up to 5 and our y values go up to 20. So I'm going to make the y-axis go up in 2s. So 2, 4, 6. I'll just write this out for now. 2, 4, 6, 8, 10. So I'm actually going to leave out this point as well, so it doesn't get too crazy. And 3 points should usually be enough. Minus 5. So minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. And negative values, negative 2, 4, negative 6, negative 8, negative 10. Okay, so not to dwell on this too much, but I've taken a lot of time in establishing the intervals that I want. So the intervals along the x-axis are going they're going up in 1s, and the intervals on the y-axis are going up in 2s. So you're free to choose. If you want to have different interval lengths on different axes, that's perfectly okay, as long as you just specify it. So here it's specified because there's 5 intervals and it goes up to 10, so we know the length of each interval is 2, and over here it's also specified because we know the length of each interval is 1. There's 5 notches for 5. Okay, so that's the hardest part of really drawing these graphs. And what I'd like to do, if there's time, is I'd like to show you how to plot the graphs on Excel. I've sent you the solutions for one of these graphs. We have plotted it in dot form. I haven't joined the dots, but it gives the overall shape of the graph. And I think it would be an interesting exercise for you to try. And also you can always check your answers as well. If I give you homework and you get something in the textbook but you're not quite sure how they got it, you can plot it directly on Excel. It will do it without having to find things like turning point and asymptote and stuff like that. It'll just plug the information and show it graphically. So now let's get plotting. So negative 5 and 1. So remember, 1 is halfway, negative 5, negative 1. So negative 1 is halfway between these 2 points because we said the interval length is 2. Then we've got negative 1 and negative 5. So we've got 2, 4, negative 5 sits there. And negative a half and negative 10. Okay, so that should be good enough for our lower branch, and our upper branch will be mirrored. So we'll get a half and 10, 1 and 5, 5 and 1. Okay, so it would go like this. Okay, now we need the other graph, y equals 5 over x. So this graph, y equals to x over 5. So if we think of the standard equation for the straight line graph, y equals mx plus c, we could write this graph as y equals to 1 over 5x plus c. So the value of c in this case is 0. Okay, so that means our y-intercept is 0 and that this graph passes through the origin. So this is one of the points of the straight line graph. Okay, and we just need one other point. Remember, for a straight line, all we need is 2 points and we just put a line through them. Okay, so I'm going to pick 5. So if x equals to 5, we have 5 times a fifth, which is 1. Okay, so that goes there. And then we just pick minus 5 as well. That will be minus 1. And this graph would do something like this. Okay, so maybe not the best scale that I've chosen because the straight line is very flat, but you can still see what's going on. So for 1a, it's also asking what is the domain and range for each graph. Okay, so for a straight line graph, for this graph here, we can put any value of x in that we like. We could put 1, 2, 3, halves, irrational numbers. We could put in 1 over 5 pi. We can pick any x value that we like. Okay, so our domain, and if we have our notation for any value is x is an element of the reals. Okay, so you might recall what real numbers are from grade 9 at the beginning. So x can be any real number. Okay, so the way this graph is looking as well, it can take, if you look at the x-axis, it can take any x value on the x-axis, and it's also getting bigger and bigger along the y-axis. Okay, so if you imagine if this graph went on forever, this graph would continue rising forever. And on the other side, if x was decreasing forever, this graph would continue decreasing forever. So the range is defined as the list of y values that this graph can take. So we can see these y values are taken, and basically any y value can be taken. Okay, as x increases, this graph increases and all y values there, and as x is decreasing, we have all these y values. So the range is also y is an element of the real numbers. Okay, so there's very little space here. I'm just going to rub out. Oh, I shouldn't have rubbed that out. I'm going to rewrite it. Okay, let's try and neaten here a little bit. Okay. Domain x over 5. And now let's look at the other graph, y equals to 5 over x. Okay, so the domain is all the x values that this graph can take. So the only value we can't have for x is 0, because we can't divide by 0. So our domain is x is any real number, and x cannot be 0. Okay, so that specifies everything except for 0. Okay, let's see what the range is going to be. So the range can also be determined when we look at this graph. We see that it can take any y value except for 0. This graph never touches the x-axis here, and conversely in the mirror image it never touches the x value here. So this graph gets closer and closer to 0, but never quite reaches it, and it's a horizontal asymptote. So similarly, the range for this graph is going to be, look, y can take any value up there or up there except for 0. Okay, so we are moving quite slowly here. So I'm just going to do one more question from question 1, and then I want to jump into question 2. Let me pause the video.